saying that this velocity is 3 meters per second, right? This velocity is 3 meters per second, and the answer that we got in here, the velocity that we got in here was 4 meters per second. So is this possible? Is this possible, guys? Yeah, is this possible? So this, I'm going, right, whenever I throw an object in the upward direction, whenever I throw the object in the upward direction, so I am throwing it against the gravitational pull. So it is going against the gravity. So my speed will always decrease, right? My speed will always decrease. So whatever the velocity that I'll get in here, that would always be lesser than this one. So there is some mistake in the calculation for this one, right? And the crucial point that we have to always remember, that whenever we are going upwards, right? So please note this thing down. So let's quickly, I will solve this question correctly. And I will write the correct solution, but this thing you have to note it down. So always keep in mind that whenever, right, let me just talk about that. Yeah, so always remember, write this in notes, right? Note it down somewhere, that whenever you are going upwards, right? So work done, that would be negative. Whenever you are going upwards, so your work done would be negative. And whenever you are going downwards, so due to gravity, the work done would be positive, right? So this thing always you have to be very careful. So if you miss this thing, then you'll get the wrong answer. So work done would be negative whenever you are going upwards. And this is attributed to the potential energy, because potential energy is positive, mgh. You get positive mgh. So your work done would be minus of mgh, right? So this thing you have to always remember, right? Okay, please note this thing down. Note it down somewhere. Note it, guys. Yeah, noted. So when we solve this one, right, when we solve this one, so the object was going downwards. Then work done would be positive. So then we wrote work done was positive. But, and in the previous question as well, right? So in this one also, the object was going downwards. So whenever the object is going downwards, you take the gravity part positive. So this thing you have to keep in mind, right? And whenever we are throwing the object upwards, then the work done would be negative. So this thing you have to note it down. Okay, yeah, and then when you will do the calculation using this thing, so you will get the correct answer. So the correct answer would be, right, work done is half mv final square minus half mv initial square. Work done is minus of mg, and 0.5 minus 0.5 cos 60. And this is initial speed is, so this is half mv square at this speed, at this part. And initial speed is, you guys have already known, right? So this is 3 into 3, so 9 by 2. So what was this? This was half, as we calculated. And this was half mv square minus 9 by 2. So this two will cancel, right? And this m is also cancelled. So you have, right, so this was, okay. So this was half mg by 2 and all these half got cancelled. So this was minus 4, right? So why am I getting, okay. So this was 0.5, right, by 2. So there was this 0.5 as well. So this was by 10, so this was by 2. So this was minus 10 by 2, which was minus 5, and then v square minus 9. So this is minus 5 plus 9 v square. So v would be 2 meter per second. So this would be the correct answer. Okay, clear this one. So this should be negative. Right, this is the very crucial thing. Whenever the object is going downwards, work done would be positive. Whenever the object is going upwards, going against the gravity, then work done would be negative. So is it clear? Please correct this one. Quickly correct this one and then we'll start the next chapter. Clear, everyone? Yes. Yeah, so please note it down quickly and then correct that part in your notebook, and then we'll move on to the next chapter, which is current and electricity. Done, everyone? Okay, so now let us start the next chapter, which is current, electric current. Right, and you have to just note down few things. Whatever part you have to note it down, I will just tell you to note it down, and some things I will be discussing. Right. So what are the things that you guys already know? Right. So current is flow of charges. So this is Q by T. But average current is delta Q by delta T. And instantaneous current is dQ by dt, right? And the slope of this graph will give you the I average, right? So slope of QT graph will give you the average current. Okay. So this thing you guys already know, right? And then we have in IT graph, whenever we calculate the area under IT graph, so that will give you the charge, right? So this thing you have to keep in mind. And then you have this drift velocity. So all these values you guys have to remember, right? So drift velocity is E tau by m. And then this is the relation between drift velocity and current, which is NEAVD. And these things I will not talk about because these things are new and you guys have already done, right? So current is related with drift velocity by this formula. And then this is the Ohm's law in macroscopic form, right? So this is the ohmic behavior, linear behavior, and when it is non-linear, then the material is non-ohmic. And this Ohm's law is also written in the microscopic form, right? In microscopic form, this is JE. So this is written as, where is that? So this is the microscopic form. J is sigma E, right? Where J is the current density, sigma is the surface charge, and E is the electric field. So this is the thing that you have to remember, and you have to also remember that how do we write this resistance, right? So this resistance is denoted by this, right? And this is also related with this resistivity, which is rho L by A. And rho is related by this relaxation time and this mass of the electron. So these results, you guys have already you guys already know, and you have to just recap those things, right? So if you guys want to know all these formulas one by one, I will just show the screen. Or if it is okay with you that I move on, so I will just move on to the next point, right? So do you guys have these notes already? These formula that you guys have these notes of these formulas? Or do you want to note it down? Yes, everyone. Yeah, so do you guys have your short notes in which you have written these formulas? You guys have those notes? Yeah, so you have to remember what I am saying is that you have to remember that what is, okay, who got, yeah, so you guys have to remember what happened. Yeah, so what is happening this to this pen? Okay, so what is happening to this thing? Yeah, let me just close this thing and then start it again. Yes, I'm asking that do you guys want to note this thing down? Why you guys are so silent today? You guys have to just note down the formula. That is only the important thing, right? So you guys have to remember these formula, and this will help you to solve all those questions. So no need to derive, no need to prove anything, right? Yeah, so I have somebody has written in the chat box what you guys are saying. Wrote it, noted, sir, already. Okay, noted. Okay, yeah. So you guys have to just remember that what is the drift velocity, what is the relation between the current and drift velocity, what is the resistivity, what is the mobility, what is the conductivity, and what is the current or what is the Ohm's law in the microscopic form. So all these things you guys have to remember, right? Okay, but the thing that we have to discuss is the resistance. Oh, what is this thing? Okay, so let's discuss the resistance of different materials. And these are the question that has been asked in the previous exams, right? So let's talk about these parts. Okay, so we will find out the resistance of specific materials. So can you guys tell me that I have, let's say I have this box, this cubical box, right? Let me draw it like this. So this is some material, conducting material, right? This is some conducting material, and let's say that the length is A, the breadth is B, and the height of this material is, let's say, C, right? This is the height. So can you guys tell me how many surfaces this material will have? How many surfaces this material will have? Yes. How many surfaces would this material will have? Can you guys, can anyone tell me how many surface this material will have? Yes, Tari, if you have done this already, right? So you should remember this one. How many
Six.
surf? Six, right? So this has six surfaces, right? Let's say this one is one, then this one two, then this bottom one three, and then upper one four, and then we have this front one. So this one is front five, and then this back six, right? So we have six surfaces. Now you can imagine your home, right? That is a cubical shape. So your room is not cubical but cuboidal shape. So your room is cuboidal shape, and you can imagine that your floor and then your ceiling, right? So that is the other surface. So this would be the floor, right? And this would be the ceiling, right? So this is the ceiling, and this would be the floor. So if I ask you that what is the resistance between the ceiling and the floor and the ceiling, so this should be how much? Because this is the same material, so its resistivity will be same, right? Then we have to find out the length between 3 4 and area between 3 4. So that would be the resistance, right, guys? Is it clear? Is it clear?
Yes.
So what would be length between 3 and 4? What would be the length? What would be the length between the floor and the ceiling? What would be the length? Yes, guys, what would be the length?
C.
C, absolutely correct. So this is C. And what would be the area of the floor? What would be the area of the floor?
A into B.
A into B. So that is the resistance between 3 and 4. Good. Okay, so can you guys tell me what is the resistance between 1 and 2? Please find that out and tell me. So let's say these are the four walls that you have. So you are finding out the resistance between the opposite walls, right? So this wall, let me choose a different color. Maybe this color will be fine. So this wall and this wall. So what is the resistance between wall 1 and 2? What is that? Yeah, rho A by BC. So ER is saying Iyad is saying rho A by BC. Okay, yes. What about rest of you guys? What do you guys think? Yes. What do you guys think? Fadil, Madia, Tarif, Shahid, what do you guys think? What would be the answer? Yes, are you guys here? Or are you guys sleeping? You guys can respond, right? Whatever answer you guys are finding. So please, whatever answer you are finding, please tell me whatever is the answer. Don't think about anything, whether it is wrong or right. Please tell me whatever the answer that you guys are thinking, which is correct. So, yeah. First thing is that you guys need to think, right? And if you have crossed that stage, then everything would be easy afterwards. So first thing is that you have to think about the answer. Whatever the answer is, wrong or right, right? So everybody can make some mistakes. Yes, everyone, any answer you guys, if you guys can't speak, then you can write it in the chat box. You guys were responding earlier, right? When I was doing this motion in 1D vectors and all those things, you guys were responding. But this is the recent topic, electric current, that you have done recently. Tarif, we have done this same question before. Same question, I'm just repeating that. What about you? Okay, so yes, Iyad, you are correct. Absolutely correct. So this is the area, right, which is B and C. So area is BC and the space between this thing is A. So length is A. So that is rho A by BC. And you guys can think that what would be the resistance between what is the remaining one? 5 and 6. This you guys can think of. So this is the resistance of this cuboidal shaped material. Now, what would be the resistance of the cylinder? Right, resistance of a cylinder, a hollow, not the totally hollow, but partially hollow. So first we have this, right, we have this cylinder. If I do this thing, will it be, oh, we don't have the cylindrical shape. Okay, that is what we can do. So we have this cylinder. And then we have this hollow one. So this is the hollow cylinder. Right. And first thing is that this radius is A, right? And this radius, the bigger one is B. So if I ask you that what is the resistance between the ends, between the cross section? So first question is, what is the resistance between cross section? When I say cross section, what do I mean by that? So this is the cross section, right? This one and this one. So what would be the resistance, guys? Can you tell me? What would be the resistance? Resistance, and let's say material has resistivity rho. So rho is always uniform, right? Rho length. Okay, so I have not mentioned this length. Let's say this is L. So what would be the resistance? That would be rho L by area. What is the area of cross section? That is simply rho L by area of cross section is bigger circle minus smaller circle, because this part is not there. So pi bigger circle, the whole circle is B square, minus smaller circle, a square. So how much is this thing? This is rho L by pi b square minus a square. This is the resistance of cross section, right? Is it clear, guys?
Yes.
Okay, so this is one part. Now, this question has been asked in JEE mains, right? And this is the question that we will talk. So, the resistance between inner part and outer part, right? So, we are finding out the resistance between this part and then this part. So, whole cylinder, right? So, what we will do is that to do this kind of calculation, we will assume a cylinder, right? We will assume a cylinder in x distance. So this is at x distance, right? And then what would be the area of this thing? So what would be the area of the cylinder whose radius is x, length is L? So curved surface area, right? So the small resistance dr, that would be rho dx divided by this area, right? Which is how much? So dr is rho dx, and this area of the cylinder, black one, is 2 pi x into L, right? So this is the small resistance. If I want to calculate the whole resistance, so I will integrate both the sides. So I will get integration of rho dx divided by 2 pi xl. And what would be the limits, guys? Can anybody tell me what would be the limits? What would be the limits of this integration?
A to B.
A to B, absolutely correct. So this is these are the limits of integration. So rho is constant, L is constant, 2 pi is constant. So everything is constant. We will take it outside. Rho by 2 pi L constant. And then this is integration of, so integration of dx by x. So how much is this thing? So this is rho 2 pi L, and this is ln x from B to A, right? So this would be how much? This would be rho by 2 pi L and ln of B minus ln of A. So I can write it as ln of B by A. So this would be the answer. Okay, so this is the resistance between the inner part and the outer part. Is it clear, guys? Is it clear?
Yes.
Okay, so quickly note down this part, right? Quickly note down this part, and then we will talk about another question which has been asked in the JEE. So we'll understand that one, and then we will talk about the other part, which is temperature dependence, right? Yeah, whenever you guys have noted it down, please tell me. And we will speed up and yeah, let's see. Yes, noted everyone. Noted everyone. Yes, guys, noted. Write it in the chat box. Okay, who texted me? Yeah, so okay, so you guys have noted it down. Now let's try to find out the resistance. Right, so let's try to find out the resistance of a material which is partially hollow sphere. So this has also been asked in the JEE, right? Resistance of a partially hollow sphere. So how much is the resistance, right? So we have this inner part, which is a distance, and then we have this outer part. And this is filled, this part is filled, right? So this part is filled. And the question is, what is this distance is B? So question is, what is the resistance between this point and this point? Right. So again, we will assume a sphere of radius x. Right. So what is the area of the sphere? What is the surface area of the sphere? So resistance would be small resistance. This would be rho dx divided by the area. So this is how much? Rho dx divided by area, which is 4 pi x square. This is the area, right? And if you want to find out the total resistance, so that would be how much? Integration of this thing. And again, the limit would be a to b. So what would be the answer? 4 pi rho taken outside, and we have dx by x square. That is a to b, right? So how much would be this thing? So rho by 4 pi, and we have x square. So that is x minus 2 plus 1 divided by minus 2 plus 1, right? And the limit is b to a. So how much is this thing? So this is rho by 4 pi and x minus 1 and minus 1 b to a. So what is this thing? We can take this minus outside. So this is minus rho by 4 pi and 1 by x limit b to a. So what would be this thing? Minus rho by 4 pi and then 1 by b minus 1 by a. So we can write this is ab, b cancel. So we have a cancel, we have b. So this would be, this minus goes inside. So rho B minus A divided by 4 pi AB. So this would be the resistance of the hollow sphere. Is it clear, guys? Is it clear? Good. So now you guys please note down this part. So quickly note down this part, and I will just give a glance of whatever you have learned, right? So resistance we have talked about, resistivity we have talked about the drift velocity, all those things we have talked about. So using those ideas, we'll talk about, or we will understand the other things, right? Whenever you guys have noted it down, please tell me. Yeah, whenever you guys have noted, please tell me. Okay, so noted. So now let's talk about the temperature dependence of this resistance, right? So that part you guys have already you already learned, right? I'll just show you the formalism, right? So what is the important thing that I have to talk about? Yeah, so where is that? Yeah, so this one is there. So this is the temperature dependence of resistance and resistivity. So this one is the very important result that you guys have to remember, right? This one is the very important result. So you guys just note down these three formulas. This one, and this one. So there are direct questions asked on these topics. There are direct questions. So quickly note down this thing, and then we'll talk about the other parts. Yes, noted everyone. Guys, did you guys note it down? This temperature coefficient, right? This can be directly calculated using this formula, right? So just remember this one. So if you guys have noted down this one, so let's do one question which has been asked in IIG, right? So that was a direct question, right? Where is that question? Yeah, this one. So using that idea, we can directly calculate this question. Right. So please solve this one, or let's solve this one and see what is the answer. So in this one, we have R1, which is 16 ohm. We have T1, which is 15. We have R2, which is 20. We have T2, which is 100. And then we have to find alpha. Right. So everything is given, and we know that what is alpha? Alpha is R2 minus R1 divided by R1 T2 minus T1. So let's use these things. So the R2 is 20 minus 6, and then minus 100 minus 15. Right. So how much is this thing? So this would be 4, 16, and then this is 75. So 4 fours are 16, and then how much is this thing? So 1 divided by this is 300, right? So this is we can write this as 1 by 100 and then 1 by 3. So this is 0.0033 and so on. So what would be the answer? So 0.003, this one. Right. So there is a direct application of this formula, right? So I hope that you guys get this these kind of questions that you can apply the formula directly. Is it clear, everyone? Yes, is it clear? So degree C inverse. Okay, quickly note this one down. Quickly note this one down, and then we'll do the next question. Whenever you guys have noted, please tell me. Okay, so now let's move on to the next part. So only this much we will use. There are other results as well, which talks about the power and dissipative power and heating effect of current. So we'll talk about those things later, but let's do some question using all these ideas that we have learned. So only this much we will need, and these things would be these things we can simplify, right? So one more thing that I have to talk about is this color coding, right? So do you guys remember the poem? What is the poem? Do you guys remember the poem? So the poem goes like this. Right, let me for color coding questions, and they are direct questions, and you just have to remember one poem. And if you remember that poem, then the calculation would be pretty much simple. The calculation would be direct. So let's remember the poem, right? What is the poem? So the poem is, okay, this has become very slow. So the poem is, this is color coding. Oh, what is happening? What is happening to this? Okay, so yeah, let's write it in English. So color coding. And sometimes color is written like this, or this is also you can write color coding. And what is the poem? So the poem is B.B. Roy of Great Britain had a great watch. I will write watch. Right. So if you remember this thing, then you can solve the color coding problem, right? So if you remember this poem, then you can solve the color coding problem. So what is this B? B stands for black. I should write it in this way, right? So let me write it in this way. So this is first part is black, and then this B is brown. Then this R is red, O is orange, and then Y is yellow. This part discarded. This G is green. This B is blue. This part discarded. This is discarded. This G is gray. And this W is white. So if you remember this thing, then you can write this color coding. So what are the numbers or the multiples? Multiples are 0, 1, 2, 3, 4, 5, 6, 7, 8. And then you have powers. So what are the powers? So this is 10 to the power 0, so on. And there should be 9, right? 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh, very. So had a very, right? So there is a very in between. So very great watch. So before gray, you have right. So before gray, you have violet, and then you have gray, and then you have white. So this is 7, 8, and 9. Now this is complete. So this goes up to 10 to the power 9. This is powers. And then you have the errors, right? So errors are represented in gold, silver, and no color. So gold represents 5% error. This represents 10%. This represents 15%. And what is how do we write the resistance? So we write the resistance as XY and then into power and then plus minus the R. So this is how we write. So this X color, Y color, and then Z color would be power, right? So this is Z. So Z is power. These are multiples, right? Into 10 to the, so Z power, and then this is error. So this is how you write the color coding, right? Quickly note down this thing, and then we will do one question based on this. Quickly note it down, guys. Quickly note it down, and whenever you guys have noted, please tell me. So who got disconnected? Iyad got disconnected, and then who got disconnected? Shahid is also here. Oh, Learnivio got disconnected. Yes, please note down, guys, and tell me if you guys have any question in this one. Quickly note this one down, and please tell me whenever you have noted, right? So only this thing you have to remember, and you will get a direct question. There are several direct question has been asked, and you have to only remember this thing. Yes, noted everyone. Noted, guys. Noted. So now using this idea, let's do one question, right? And this is the question. So the question number 6. Please do this one and tell me what is the answer you guys are getting. Please do this question. Let me just bring this question. Okay, let me make a page in here. So solution. Right, and let's bring that question in here. So in that way, we can solve it properly. Yeah, so please solve this one and tell me the answer you guys are getting. So the first color is right. First color is violet. Oh. And then you have green. And then you have red. And then you have gold. So what is this thing? Yeah, what is this thing? Tell me. So B.B. Roy of Great Britain had a very good watch. So, yes, what is violet? 0, 1, 2, 3, 4, 5, 6, 7. Violet is 7. And then what is green? So 0, 1, 2, 3, 4, 5. Green is 5 into red. What is the multiplier? What is the power of red? So 0, 1, 2. So 10 to the power 2. Plus minus gold is 5%. So this is the answer. 7,500 plus minus 5%. Okay, so we have two answers of 7,500 plus 5%. So what is the 5% of 7,500 into 5 by 100? This will cancel. So this is how much? 25, 35, and 237. So this is 7,500 plus minus 375. So times, right? If you go back and see the previous year's questions, you will see this question many a times. Only you have to remember this poem, right? So yes, how many of you got the answer? This was easy to solve. Yes, clear. Is this part clear, guys? Yes, clear, everyone. Yes, you guys can write it in the chat box also. Is it clear, guys? Is it clear? Okay. So then let's do the next question. So using these concepts that we have learned, let's do these questions, right? So a current through a wire depends on time. So, so this is the current which is given alpha naught t plus beta t square, and alpha and beta have some values. Find the charge crossed through a section of the wire in 15 seconds. So we have to find out current is given. Form we have to find out charge. What is the charge? So we know that I is dq by dt, right? So this dt goes in over here, and dq is I dt. So to calculate the charge, we have to just integrate this thing. Integration from, let's say, starting from 0 second to t, they have given up to 15 seconds. So this is the charge. So I is alpha naught t plus beta t square dt, and then 0 to 15. So we can integrate this thing. Alpha naught t dt 0 to 15 plus beta t square dt. So variable separable, right? And what would be this thing? So alpha naught is taken outside, and this is t square by 2 from 15 to 0. And then we have beta is outside, t cube by 3 from 15 to 0. So we take this 2 outside, alpha naught by 2, and then this is t square, right? 15 to 0, and then beta by 3, t cube 15 to 0. Oh, so we have to find 15 cube. Okay, so alpha naught by 2, and then 15 into 15 plus beta by 3, and 15 into 15 into 15. So how much is this thing? We can take out 15 into 15 common. And this is alpha naught by 2 plus this 5s are, so 5 beta, right? And now we can put the values of alpha naught and beta. So alpha naught is 20, beta is 8. So this is 225, alpha naught is 20, and then this is 8. So 225 into 10 plus 40. So 225 into 50, which is how much? 25, 10, 12, 10, 11. So 11,250 coulomb. This would be the answer. 11,250. So this was a direct question, right? We have to just integrate this thing. Is it clear, everyone? Is it clear, guys? Yeah, what is happening today? So many people are getting disconnected. So is it clear, everyone? Quickly note this thing down, and then we'll do the next question. Quickly note this thing down. And whenever you guys have noted, please tell. Yes, whenever you guys have just text me, just send me a message that you have noted, and then we will move on, right? Noted, guys. Yes, noted. Okay, so yeah, then let's move on to the next part. And next question, let's do the next question. So this one, let's do this simplest one, right? Okay, so we have this question. So we have a square, right? We have a square type resistance, right? And this has a 3 ohm resistance, this has 3 ohm resistance, this has 3 ohm resistance, this has a 3 ohm resistance. So this is the total resistance of is a 12 ohm resistance. So this is the total resistance. Now this has been folded. This has been folded to make a circle, right? So, and then these parts are connected. So we have to find out what is the resistance of this circular wire, right? Diametrically opposite for the diametrically opposite ends. So for these two ends, what is the effective resistance that we have to find out? So we know that the total resistance of this thing is 12 ohm. So what is the total resistance of the whole thing? So for 2 pi r length, the resistance is 12 ohm. So let's say for semicircle, from this part, how much is the resistance? So for pi r, this is 6 ohm. So this is how the resistances are distributed. This is 6 ohm and this is 6 ohm. So this is 6 ohm, this is 6 ohm, and we have to find out the effective resistance. This is a parallel combination. So we know that in parallel combination, what is the effective resistance, right? So effective resistance is R1, R2 divided by R1 plus R2. This is the effective resistance for parallel combination, right? So how much would be this thing? This is 6 into 6 divided by 6 plus 6. So how much is this thing? This is 36 and this is 12. So this would be 3 ohm. Right. So this was an integer type question. Right. And this simple question has been asked in JEE, right? So yeah, from electric current, there are simpler questions. So is it clear? One now who got disconnected? So one by one, people are getting disconnected, right? Yes. Is it clear? Have you guys noted it down? Quickly note this one down and then we'll do the next question. Yeah, quickly note this thing down, please. Okay, noted, guys. Yes, Madhya and Tarif, only you guys are remaining, right? So you guys are the sole survivors. Yes, whenever you guys have noted, please tell me, right? And if you guys have any doubt, please tell me, right? Don't hesitate to. Okay, so done. Then let's move on to the next question, right? So what is yeah. Okay, this one. Yes, Tarif, your voice is breaking.
Sir, can you go for 1 minute?
Yeah, yeah, okay, yeah. So you were noting it down.
Yes.
Okay, okay. So now you are speaking. Yes, Tarif, why have you become so silent? So yes, whenever
Nothing, sir.
you, yeah, whenever you have noted it down, please tell. And these things we have done it together, right, Tarif? Madiha in the
Yes,
midway,
sir.
yeah. So she went off, but you were there, right? So she focused on the CBSE portion. So now she's back. And yeah, whenever you guys
So done.
have done, please don't hesitate to ask, right? So because remember, what is the goal? Goal is to solve 8 questions. And yeah, we have done half of the portions and only the half of the portions are remaining. So if we do these parts, then 8 questions we can easily do. So we can achieve our target, right? The target that we have set, we can achieve that. So let's do this question, right? So we'll do 2 questions more, right? What would be the question? So, okay, we'll do this one and maybe 2 hours of shape length specific resistance are connected in parallel. Yeah, so this one and this one we'll do. And then we'll move on to the next topic. Okay, so what is this question? Did I zoom out this thing? No. So you have this question, right? And there are two scenarios. So case one is that this switch is open. So case one is right. The ratio we can shown in the figure between a switch is open, switch is closed. So case one. Case one, switch is open. And we have to find out the resistance between A and B, right? So switch is open, then this would be the overall circuit. There would no current would pass through this thing. So this is the overall circuit, right? This is A, this is B. So these are in series. This is in series. So overall diagram would be what? So if we solve this thing, so effective diagram would be 3R and 3R, and then these are in parallel. So then what would be the R effective if we have two resistances? So R1 into R2 divided by R1 plus R2. These are in parallel. So 3 into 3 divided by 3 plus 3. How much is this thing? 9 by 6. So 3 by 2. This is the effective resistance for switch is open case. Case second, switch is closed. So if switch is closed, right? So this part, and then you have this part, switch is closed, and then you have this part and this part, right? And then you have this thing. So this is B, this is A. This is R, this is 2R, this is 2R, this is R. So These two are parallel, these two are parallel, and the overall is in the series. So let's find out what is this R effective. So we'll calculate this thing in here. So 2R into R divided by 4. So this is 3R, right? So this should be R and R, and R. So this is 3R by 2. Okay, this is 2R into R divided by R plus 2R. So this is 2R square divided by 3R. So this is 2R by 3. So the effective diagram of switch is closed. That would be 2R by 3 and 2R by 3. These two are in series. This is A, this is B. So what would be R effective? This is in series, so this would be simply 2R by 3 plus 2R by 3. So that is 4R by 3. Right? So we have two resistances, 3R by 2, 4R by 3. Would be 3R by 2. What was the ratio? 3R by 2 divided by 4R by 3. So this will go upstairs, this two will go downstairs, R and R will be. So we like what is this ratio? Oh, I guess I got disconnected, right? Who is the host now? Oh,
I think
Tariq,
it's
you are.
me.
Oh, so please
Mm.
make me the co-host. This time I got disconnected. So please make me the host, Tariq. Thank you, thank you. So yeah, let's move ahead, right? Yeah, so I don't know what is happening to the internet. Everybody's internet is fluctuating a lot. Okay, so is this part clear, guys? If it is clear,
Yes,
please
sir.
note. Yeah. Then no, have you noted it down, everyone, Maria and Tarif? Did you guys note it down?
Yes, sir.
Okay, good. So now let's do some question on right. So These are the question that you guys should practice, but we will do this one and this one. So let's do this one first. But before I proceed further, so what remains constant or what remains uniform in series combination and what remains uniform in parallel combination? Tarif, what remains same in series?
Sir,
Yes,
can you repeat?
what remains the same in series combination? This is the most important thing that you have to remember. What remains the same in series combination? So current remains the same, right? Current remains the same in series, voltage remains the same in parallel. This thing we have to remember, right?
Yes.
That is how you got this. Yeah, so that is how you got the effective resistance for parallel and series combination. So that is the idea you use. So we have this question, two wires of same length, right? So length L1 is equal to L2, that is L, length is same. We have having two wires of same length and thickness having specific resistances R1 is 6 ohm and ohm centimeter. Oh, what is this thing, right? Specific the effective resistivity is oh, so this is rho. Rho 1 is given, right? So specific resistance means rho 1, right? So we have to identify with units. Rho 1 is 6 ohm centimeter. Rho 2 is 3 ohm centimeter. Right. Same. So area is also same. A1 equal to A2, that is equal to E. So then we have to find out what is the effective resistivity. So we know that what happens in this parallel combination. In parallel combination, this is the effective resistance. Right, this would be 1 by R1 plus 1 by R2. And we know that what is R in terms of resistivity, that rho L by A. Right. So this is the thing. Now what would be this thing, right? So if they are connected in parallel, so R effective would be how much? That would be rho, and this length is same. So that would be L divided by area is also same. So that would be A. And this is rho effective. And this is equal to 1 by rho 1L divided by A. And this is again rho 2 L divided by A. So L cancel, A cancel, and 1 by rho effective, that is 1 by rho 1 plus 1 by rho 2. So we can calculate rho effective as rho 1 into rho 2 divided by rho 1 plus rho 2. So how much is this thing? 6 into 3 divided by 6 plus 3. So 18 by 9, so that is 2. So 2 ohm centimeter. This would be the answer. Is it clear, guys? Is it clear?
Yes, sir.
Yeah, quickly note this one down and then we'll do the last question. And then we will move on to heating effect of current. So I will take 10 minutes more and then we'll start and then we'll stop. Yeah, whenever you guys have noted it down, please tell me. Yes, whenever you guys have noted, please tell me. Yes, noted, guys.
Yes, sir.
Do this one question quickly, and then yeah, we'll talk about. So this is the question, right? Okay, so in this one, a current of 6 ampere enters one corner. So here the current is entering, right? And then it is going in this direction and in this way. And then it is going in here and then it is going in here. So two paths this current is following, right? So this 6 ampere, this is divided into two parts, I1 and plus I2. So I1 plus I2 is 6, right? So we can write that I2 is 6 minus I1. This is the first relation that we have. So this is I1 and this is 6 minus I1. So these are the two currents. Now, if we talk about this thing, so what would be the voltage? What would be the voltage through this point and what would be the voltage through this point? Right. So if we see at this point, PR, so voltage at PR, that would be equal to voltage at this PQR, right? Because this combination is parallel. So this is PR and this is PQR. So we have two resistances. This is 2 ohm and this is 2 ohm and 2 ohm. And this is PR. So these are parallel, right? So voltage would be same. In parallel combination, voltage is same. So what would be the okay, so only Madhya is left, right? So okay, we'll stop here and we'll continue in the next class, right? So only you are remaining. Yes, Madhya, can you hear me? Okay, so only you are remaining, so we'll stop, right? Because everybody has, oh, so Tarif has come back. Okay, so one moment. We can do this problem, right? So internet is fluctuating a lot today, right? Internet is fluctuating a lot. Okay, so Yes, what is happening with your microphone, Tarif? Yes, Tarif, your microphone is not showing. Yes. Okay, Tarif's microphone is not showing. Let's wait for 1 or 2 minutes for Tarif and then we'll. Oh, now it's working. Yes, hello, Tarif. Can you hear me, Tarif?
Yes, sir.
Yeah. So this was the question that we were doing. So we discussed that 6 ampere is flowing through this circuit, and then it is getting divided in two parts. So one part is I1, the other part is 6 minus I1. But this PR circuit, this PR and then this PQR, right? These are in parallel. So voltage through this thing, that voltage would be equal to this VPQR. Both the voltage would be same because these are in parallel. So what is the voltage in PR? That would be current in PR into resistance, which is PR. And then VPQR. So current in PQR and then resistance in PQR. So how much is this thing? I is I1, or this PQPR is 6 minus I1. So 6 minus I1 into 2, and then this is how much? I1 into 2 plus 2, because this is in series. So that is 4. So this 2 and this will be cancelled, and this is 6 minus I1. This is equal to 2I1. So we have 6 equals to 3I1. So I1 is 6 by 3, which is 2. So 2 amperes. So I1 would be 2 amperes. Is it clear, everyone? Is it clear, guys? Yeah, just noted this one down and then we'll stop, right? Because so many people got disconnected. So we'll stop here and we'll continue from the next class. Yes, noted, everyone. Yeah, please note this one down and then we'll stop.